Okay, hello students, how are you? Today our lesson is cell notation, yes? Cell notation. How can cell notation mean what? It is a systematic representation of what? Of cell without using diagram. Without using diagram, which one is anode, which one is cathode? To identify this, we have to use cell notation. In cell notation, don't forget this very important point. Always write the anode. Write the anode and slash the anode electrolyte and vertical line. You know that students, vertical line means it is salt bridge, and cathode electrolyte, this is the 4. This is the 4. Here already the notice part, the slash represents what? It is the anode metal, and the electrolyte of the anode should be, it is separated, and the double arrow represents salt bridge. You know that what is salt bridge means. For example, here, the Daniel cell can be represented. You know that Daniel cell, in Daniel cell, zinc metal is immersed in zinc sulfate solution, whereas the copper metal as cathode immersed in copper sulfate solution. And without using the diagram, the cell notation for Daniel cell will be this. From this, what can understand? Zinc acts as what? As anode, whereas copper acts as what? As cathode. Next, important points in reduction potential value. In reduction potential, students, you have this table on your textbook, you can refer, but I need to explain very important points about the reduction potential values. In reduction potential values, always you should read the half cell reaction from left to right as what form? As reduction form. All are in reduction form. What does it mean? Here, all are reduction. F2 from 0 state to -1 state. Copper +2 to 0 state. You can refer your textbook, or you can use this slide. All equations from left to right, they are written in what form? In reduction form. This is very important. The other one is what? Always in galvanic cell, the one with less reduction potential value, it acts as what? As anode, whereas the higher reduction potential represents what? The metal or rod acts as what? As cathode. For example, in Daniel cell, here in Daniel cell, we have zinc and copper. The chemical reactivity of zinc and copper, zinc is greater than copper, that is why zinc acts as anode, and copper is what? It is as cathode. These are important points. The other one, it is the more positive reduction. The metals near to the top series are strongly electropositive. What does it mean? The more positive reduction potential, they have greater tendency to be what? To be reduced. What does it mean? For example, take this table. F2, by gaining 2 electrons, it changes into F minus. The reduction value is 2.87. It is the highest of all. You can refer all are what? From the all, it is the highest of all is, it is for fluorine. What does it mean? Fluorine has the highest reduction potential value, implies what? It is the most what? Oxidizing agent, and it can easily get reduced. The other point, from all, the least value is what? It is lithium. The reduction value of lithium from +1 to lithium is, it is -3.05. It is the least reduction potential value, implies what? It is the most reducing agent, and it means what? It can easily get what? Oxidized. These points are very important. And the other one is what? It is intensive property. Intensive. When you multiply the half reduction, it doesn't change the value because intensive. And the other one, when you reverse the equation, just convert only what? Only the sign. For instance, the reduction of lithium, how much is it? It is -3.05. When you reverse this equation from lithium to lithium plus, the sign of negative is changed to what? To plus. This implies what? When you reverse the equation, always multiply the half cell reaction, means reduction potential value, by minus. The next important point is E of cell. How can you calculate E of cell from the reduction potential value? Here we have the equations. E of cell can be given as E of reduction at cathode minus E of reduction at anode, or you can use these two equations. Don't forget, students, E of oxidation at anode always is equal to what? E naught of reduction at anode. Here we have example. Here in galvanic cell, the values are given for anode, magnesium to magnesium 2 plus, E of reduction is 2.37. It is not reduction. Sometimes the standard already I told you it is in reduction value, but sometimes you may give what? It is oxidation. Magnesium is oxidized here, and silver from plus to 0 means it is reduction. So how can you calculate? The formula here it is what? E of cell can be calculated by E of reduction at cathode minus E of reduction at anode. But we don't have E of reduction at anode. Rather, what is given? E of oxidation at anode. In this case, you can use what? You can use this, the second formula. E of reduction at cathode, how much is it? 0.8 plus E of oxidation at anode, how much is it? It is 2.37. The sum of the two it gives 3.17. Or the second approach, the same question where reduction potential is given. In the previous, for magnesium, oxidation is given. Here it is reduction from plus 2 to what? To 0. In this case, how can you solve? How can you solve here? Mg is given. It is reduction from plus 2 to 0. Already this one is reduction. The reduction values are given. But the formula is E of cell is equal to E of reduction at cathode minus E of reduction at anode. This is equal to E of reduction at cathode. How much is it? E of reduction at cathode. We know that silver is cathode. Therefore, reduction is 0.8 volt. Minus, open the bracket, E of reduction at anode. The relation between E of reduction at anode and E of oxidation at anode, one is the reverse of the other. In oxidation part, what is given? It is positive, but the reduction is negative. So here, negative 2.37 volt. Together, minus minus plus, it is 0.8 volt plus 2.37 volt. You will get what? The same answer, which is 317 volt. So sometimes you may have reduction values, sometimes you may have what? You may have oxidation. So you can use this to approach. In different concept, in different approach, we get the same result, 3.17. Here also it is 3.17. This is how to calculate.